Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. Imagine a single part of a quadratic question costing students across exam boards dozens of marks last year. Not because the maths is hard, but because they treated the method like a magic trick and skipped steps. If you stick with me for the next 12 minutes, you will never lose those marks again.
Section 1. The concept. Start simple. Completing the square is a way of rewriting ax squared plus bx plus c, so it looks like k times x minus a squared plus b. Why do we do that? Because that form tells us the vertex of the parabola straight away, the turning point, and makes solving and sketching much easier. Let's work through a clear example step by step. 2x squared minus 8x plus 3. First step, factor the 2 from the x squared and x terms only. Write 2x squared minus 4x plus 3. We leave the plus 3 outside because it wasn't multiplied by 2 originally. Next, inside the bracket we want a perfect square trinomial, x squared minus 4x plus something. The rule is take half the linear coefficient and square it. Half of minus 4 is minus 2, squared gives 4. So we add and subtract 4 inside the bracket. Add 4 to make the square, subtract 4 to keep equality. That looks like 2x squared minus 4x plus 4 minus 4 plus 3. Group the perfect square. 2 times x minus 2 squared minus 4 plus 3. Now distribute the 2 back. 2 times x minus 2 squared minus 8 plus 3, which simplifies to 2 times x minus 2 squared minus 5. And there it is, completed square form. The vertex is at x equals 2, y equals minus 5. That's the turning point we can read off directly.
Why does that method make sense, not just work? Because completing the square turns the expression into a scaled version of a perfect square plus a constant. The perfect square, x minus a squared, is symmetric about x equals a, so the parabola's axis of symmetry is x equals a, and the constant outside shifts the whole graph up or down. When a is not 1, factoring it out keeps the arithmetic inside simple, a small step that protects you from sign errors. Let that sink in. The algebra is doing geometry for you.
Section 2. Exam technique and quick news recap. When a GCSE question asks you to complete the square, it often carries 4 or 5 marks. Here's a typical 5-mark layout examiners expect and how marks are awarded. M1 for rearranging the equation into the form where completing the square is obvious, for example factoring the leading coefficient from the x terms. M1 for the actual completing the square step, showing the perfect square formed. A1 for identifying the vertex, the coordinates a and b, and A1 for the final simplified expression, or the correct solution if the question asks you to solve. So even if your arithmetic slips at the end, writing the rearrangement and the completed square can pick up 2 method marks. Examiners want to see method. Write it down, don't just think it. Common penalties I see: not factoring the leading coefficient when it's not 1, dropping the minus sign when halving the middle term, and failing to show the added and subtracted term so the examiner can't award the method mark. News recap, where completing the square shows up repeatedly. Graph vertex questions, finding maximum or minimum values, solving quadratic inequalities, and turning points in kinematics problems. Examiners across AQA, AdExcel and OCR report the same mistake: rushed working that hides the method. Marks are there for the taking.
Section 3. Quick win and worked example. Quick win first. A 10-second sanity check. After you have k x minus a squared plus b, expand it back quickly in your head or on paper to check the middle term and constant. Remember, k x minus a squared plus b expands to kx squared minus 2kax plus ka squared plus b. Compare that to your original ax squared plus bx plus c. The coefficients must match. If they don't, you spot the error in seconds. Also, simple recognition trick. If the coefficient of x squared is not 1, factor it from the x squared and x terms before completing the square. That's your immediate flag to factor k first.
Now, a worked example under exam conditions. Talk it through as you write. Complete the square for 2x squared minus 8x plus 3 and give the vertex. Step 1. Factor 2 from the x terms. 2 bracket x squared minus 4x close bracket plus 3. Step 2. Half the minus 4 is minus 2. Square to get 4. Add and subtract 4 inside the bracket. 2 bracket x squared minus 4x plus 4 minus 4 close bracket plus 3. Step 3. Write the perfect square. 2 bracket x minus 2 squared minus 4 close bracket plus 3. Step 4. Distribute and simplify. 2 bracket x minus 2 squared minus 8 plus 3 equals 2 bracket x minus 2 squared minus 5. Read off the vertex 2, minus 5. Marking notes. Your rearrangement and showing the added and subtracted 4 nets the m1. Forming x minus 2 squared nets the second m1. Writing the vertex gives the a1. The simplified completed square expression is the final a1. Even if you then made a small arithmetic slip, you would still have method marks on the page.
Practice prompt. 2 short tasks you can do now. Task 1. Complete the square for x squared plus 6x plus 5 and find the vertex. Aim to write your method clearly in 1 minute. Task 2. Complete the square to solve 2x squared minus 8x plus 3 equals 0. Use your completed square form to find the exact roots and then check by expanding back. These 2 quick practices will cement the habit of showing method and using the expansion check. That's your quick win for today.
If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Visit the site for a free pack of completed square examples and timed practice questions. Stay curious.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.